Welcome back. This is an Aleks homework video on using an integrated rate law for a first order reaction. Okay, an integration is a calculus operation. So an integral of a rate law is just taking the rate law for a first order reaction and then doing an integration on it, and that you will have a formula. And unless you want to derive that calculus yourself, I would simply just write down the formula and use the formula. Okay, so it's not as hard as it might seem. So I need a first order rate law, and a first order rate law is simply going to be the rate is going to equal to the constant, whatever the constant is, and we see that our constant is given up here, times the concentration in molarity of whatever our stuff is. Now, the stuff we have right now is an acid, an iodic acid here. So we've got rate equals K times the molarity of the concentration. So the integral of that, to take a calculus operation, I would just memorize it or write it down, is the natural log, which is, you'll have a natural log button, it's an LN button on your calculator, times the concentration of whatever we're looking at, over the molar concentration of the original, whatever the original, so that's A sub 0, if you can see that, equals minus KT. All right, so you're simply going to fill in what you can. So the first thing I see is my molar concentration at the beginning is 0.400 molar. So I'm just going to recopy that as the natural log of our acid divided by 0.400 molar equals, and then I've got minus times 0.251 divided by seconds. That's my K, and then my T is 2.40 seconds. Okay, seconds will cancel with seconds, leaving you unitless at the moment. Okay, so we've got the natural log. All right, so to get rid of the natural log, okay, if you remember, to get rid of addition, you subtract. To get rid of a power, you square root. So you take the opposite operation. Well, to get rid of a natural log, you're going to take something to e to the x power. So on normal calculator, it's going to be whatever the second function button is above the natural log. So on my calculator, I've got an ln button, and then the second function above that ln is e to the x. So you're going to take the e to the x. So first of all, let me do the math on this one. 0.251 times 2.4 is going to give you negative 0.60240. Okay, unitless. All right, so I'm going to put that number in my calculator, negative 0.60240, and hit the e to the x button. Okay. All right, so that will give me, let me recopy that, the natural log. All right, sorry, I don't need natural log anymore because I got rid of it. So this is now just going to be the concentration of my acid over 0.400 molar times, equals, and whatever my calculator gave me, 0.5475. I'm going to add that 0 because I've got this many places. I've got 5 places past the decimal, so I'm just going to keep it 5 places. Okay. All right, so to get the molar concentration, and that's what you're asked for, calculate the concentration in the vessel after a certain amount of time, I'm just going to multiply the 0.547 times the 0.4 molar. And so when I multiply that, I get concentration of the acid equals 0.219 molar, because I'm going to bring my molarity up. And now how many significant digits do I want? I want 2. So to 2 significant digits, I've got 0.022 molar concentration. Okay. I wouldn't call it easy, but it is, as long as you know what the equation is and you know how to get rid of a natural log, I think you'll be okay.